welcome to episode 22. We are here with a very familiar launch vehicle. This is going to be carrying a Minmus reconnaissance satellite. We've accepted a suite of contracts to do some more scanning, but this time around Minmus, which is not one we have visited before. This is basically the exact same layout as the one we took to the moon, but I've made a few adjustments here and there. I've put more fuel into that solid booster, I've increased the thrust on it, basically undid all of the limitations I put on it for the moon one, and I also put some larger fins on there to help with stability as the center of mass changes. So we now fly this thing up, and it's basically identical to the moon one, but we're just going to put it around Minmus. Delta V requirements are honestly basically the same, because we don't have a whole lot further to go. I mean, Delta V wise, it's not that different to get into a moon orbit versus a Minmus orbit, as long as you do it correctly. And yeah, so now we're going very fast now because this booster's got all the fuel in it, and you can see our apoapsis goes up pretty high. Except Minmus does seem to be in a fairly good location where I could basically just start burning, which is what I do. So extend that antenna there. This interstage, that's upper stage there, is more sophisticated than the other one. I've put some reaction wheels on it, probe core, solar panels, and an antenna because we can collide it into the surface for some seismic science. And yeah, just tweaking around with the maneuver node here before I decided it's best to just keep burning, and we've got an encounter. We'll have to do some tweaks to bring it down closer. Now here I am just aligning the solar panels. This is to avoid the mishap with the moon one where the solar panels on the payload clip through the fairing, and when I jettison the fairing, then the whole entire thing explodes. So now 250 kilometer orbit should be good enough for these scanning technologies we have on board. Just let the moon catch up to us, or the moon of Minmus, not the moon. Do a quick course correction once in a few days to bring ourselves in a perfectly polar orbit, and finish the rest of our journey there. So now, quick 10 meter per second burn just to shift our trajectory. Once that's complete, we can plot our orbital insertion and just wait until we get there. Now Minmus is very small, but it does have, that does mean its gravity is very weak, so our orbital period will be fairly long. And it has a relatively quick rotational period. I mean, objectively, it's slow. I think one Minmus day is a bit longer than a Kerbin day, but that's still pretty fast for a body of its size. Which means that we will trace a rather interesting path over the surface as we scan it. It will be very slanted. So now jettison that, and we can extend our antenna and both of our solar panels. And there you can see now how this thing was intended to be. So just point ourselves in a way that makes sense. Get everything lined up. We can perform the orbital survey on that stock scanning antenna. And now, yeah, we've already gotten the information that we're filling up some contracts, which will get us tons of funds with which we can afford to upgrade all of our facilities. So now just transmitting away the science that I can and starting up all the other scans. So we can now start to see the map fill itself out. And you can see we're filling it out in a very slanted way. But this should be good enough. The beam path is wide enough and Minmus is small enough. The other thing we have is this old piece of hardware. If you remember, this was the magnetometer experiment that we launched in the space plane to the moon. And I've been keeping it in orbit here, just filling out any contracts for science data around the moon. But we can get more science with it, because on the surface we have some seismometers. And this is a good time to decommission this and help declutter our space. So now just watching this thing falling towards the moon at escape speed, almost 1 kilometer per second, I think, was the impact velocity on this thing. Oh, more than it. Coming down now, and here we go. And you could hear a few separate explosions, which actually counts as multiple seismic events, which gives us even more science to do. So we just transmit each single one away, watch it drain our power out, we gradually recharge, and yeah. Now, this is a very familiar sight here. We've got the same space shuttle, but a few more fins on the bottom and a few more separatrons to help avoid any problems from the boosters exploding on jettison. And we're going to try to take this to Minmus. Now, it is very ambitious doing something like this. The space shuttle never went beyond low Earth orbit, but we have, with a couple of upgrades to the actual vessel and some tweaks to the payload, we should be able to take this thing, land on the surface, and then drive around to a few biomes and collect a ton of science, and then return home. Now, it will be pushing the limits quite a bit, because it will require that we fly this space plane down from close to escape velocity all the way into a safe landing. And now just finishing our orbital insertion that we've seen here. Although I did end up having a bit of a shallow trajectory, and you can see my vertical speed dropping off very quickly there. I'm trying to get my path in line with Minmus's orbit so that way I have minimal plane changes to do. But my time to apoapsis is pretty small. It's less than 30 seconds and dropping. So I start pitching the nose up fairly high. And now this is starting to be a problem because we are gradually having to back off the thrust on this thing to keep it stable. But that also means we diminish our thrust to weight ratio, so we're less effective at keeping ourselves vertical. You can see time to apoapsis 12 seconds, 11 seconds going down pretty quickly. Less than a G of acceleration, but we're going sideways fast enough that the curvature of the planet is helping out a lot. And we have the aerodynamics at this altitude to help us just a touch, even though it's probably not all that significant. And we're just gradually picking up speed here. And eventually you can see my time to apoapsis is now rising again, rising very slowly. But as we get faster and faster, we gain more and more help from the curvature of the planet, which gives us enough margins to essentially have to fight gravity less. The effective gravity, our acceleration towards the surface, diminishes because as we fall towards the surface falls away from us. So even though the actual force of gravity isn't changing, we basically lengthen our trajectory until we get it above the ground so that our lowest point is above the atmosphere, and then we will be in orbit, as orbits go. But first we have to get out of the atmosphere, and we're now basically traveling at orbital velocity, but deeper inside the atmosphere, so we're starting to get some heating, and you can see the ghost imprints of the struts from that fuel tank. I don't think the struts extensions are actually there, but I guess the calculations for the aerodynamic effects are including their former positions. So now pitching down now, and drained that fuel tank so we can just finish the rest of our orbital insertion on that main one there. And we've got about 1800 meters per second, which should be plenty to get us to Minmus and back. So now, just getting ourselves in a good plane change here. 4 degrees is a bit much, so we want to correct that as much as possible. And you can see I'm pointing off the vector there just to help combine maneuvers and finish our orbital insertion at the same time as we do this plane change. So my plan here is, you can see our orbit and the space station's orbit are not that far apart in terms of inclination. So I was planning we could go to Minmus and then on the return aerobrake, and then we might be able to rendezvous with the station using the docking arm there, which seems to be having a fun time on its own, kind of glitching around there. The robotic extensions are working just fine, except it is broken in a bizarre way. Extending it all the way doesn't seem to help, time warp doesn't seem to fix it. So the only thing that we can really do is try and save and reload. Robotic parts do tend to get a little glitchy, what with all the physics and especially having many mods, but saving and reloading seem to have fixed it. So now we can retract that arm again, fold it away into the cargo bay with those lovely colored lights, and once it is stowed, we can hide the robotic controls. And yeah. Now the plan is, I have all these science experiments, although I think I did forget a barometer on this mission. I have everything but the barometer. So we can take all the science, even in the places that we've already visited before, like low space around Kerbin, and then rendezvous with the station, and we can transfer all the science into the lab where we can process all the experiments, even the ones we've done already, for even more science returns. So we have all of these, about half of them are from Interstellar, both magnetometers, mystery goo, seismometer, materials bay, thermometer, no barometer. Yeah, that was unfortunate, an oversight on my part. So we've got our maneuver plotted. So we burn our way towards Minmus, and just, it's a pretty small burn, 900 meters per second. I mean, it's fairly significant, but it's only about half of our delta V. And actually inserting into orbit around Minmus, landing and coming back should only be about 600 meters per second, depending on how it's done. Returning from Minmus is about 300 to 400 meters per second if you fly it in an optimal way. Now we are going to come in a very inclined way, so we'll have to do some corrections at the midpoint of our trajectory. But we, can fly out, admire the view a little bit, peek out, see there's Minmus there, just a brief little crescent. Admire the interior of this cockpit. It's pretty roomy, considering it can only fit 2 Kerbals inside. So now we just warp out even further until we're in a regime where we can reasonably do some course corrections. Although first, we do have a bunch of science experiments to do. Now, we had to get the engineer out, Stelfrid, I believe. I can't really read it, it's small. The antenna thought it was stowed, so we had to just put it somewhere else so that it could extend and we could get good communications. Now perform all of the experiments, and we'll cram them back into that canister there. And yeah, we can do an EVA report, and now let's smash into the solar panels there. We can restore the mystery goo, restore the materials bay, and then we can continue to use those once we arrive at Minmus. And we're just going to repeat this a lot, rinse and repeat. Science, spam, collect everything that we can. So now we can start to do, I'm just doing it with the RCS here, bringing our trajectory in nice and close. 10 kilometers is fine, that's pretty good. And now once we arrive within the sphere of influence of Minmus, you know what that means? It means more science. So we can come back into our cargo bay, crew reports, magnetometer reports, science that we've already mostly gotten. There's a few that we had only transmitted, so we can bring the physical data back to get the full returns. And yeah, I was still relying on a station rendezvous here to process the ones we've already maxed out the science of. Although you'll see why in a bit, but that ended up not being entirely possible. Just the way the mission went. Now, falling towards the moon here, the moon of Minmus. Admiring the sunset there. And just inserting ourselves into orbit. Now, I want to land this somewhere flat. Something that is possible with a spacecraft like this is to do a grazing landing, where we basically come in almost no vertical speed, like basically fully orbital velocity, but just orbiting at the altitude of the ground. And then we can touch our wheels onto the ground and use the brakes and the engines to slow ourselves down and save some fuel. Which is fun to do, but it is risky, and it also needs a very long stretch of flat land, which is available on Minmus, except with the inclination we're at, it'd be pretty difficult, and I also don't want to just sit in orbit forever. I want to actually land these guys and get some science. Jonas and Stelfrid here. Those are our crew. And now we're going to come down over this flat part here, burn ourselves into a landing course. And I want to come down close to the hills because my plan is to drive over once we've landed and collect science from multiple biomes. So now falling, getting ourselves oriented to slow ourselves down. Well, 600 meters per second here. Now I'm just burning off with the RCS here to get a little bit more delta V out of it. Falling the rest of the way. And yeah, there's not enough room between me and those hills over there to do a proper grazing landing. So we're just going to put this thing basically on its tail and then flip over onto the wheels, and we can drive around like that. And we're going to be a little far from the hills, but it's not a totally unreasonable driving distance. Just bringing off the rest of our speed there. RCS is working hard to keep us stable. And just about 10 meters per second, letting ourselves gently fall down. And right at the last second, we will bring it onto its wheels, and nice landing. Not too bad. So now we've landed in the Greater Flats, which is a biome we've already visited before, I think once or twice. But that doesn't mean we can grab some more science. There's a few experiments that we haven't gotten, like the seismometer there. A few that we have yet to max out. And do a backflip off of the cockpit there. So now restore those, and we can plant the flag, do EVA, surface science, all that fun stuff. Plant the flag. Airplane landing. We will turn this plane into a car and drive it over to the hills for science. A lot of this we already have. So get it back inside there. One other experiment that I have is this surface sample collection drill. This is from Interstellar. And we have to retract those back wheels so it can actually make contact with the ground, but that will be just a little bit extra science that we can get from here. And collect that. And now, because I don't want to waste away any of my fuel, we just burn with the RCS to get ourselves up to speed. A couple meters per second should be good, and we'll just take a while. Admiring the view. And of course I have to go and mess everything up by pressing W with the RCS on, which flipped the entire thing over and broke the solar panels. So flip it back over. I have to be careful to not press W when the RCS is on, because these wheels I don't think they have motors, and it will also just pitch us down like it did right then. But now we can just finish the rest of the drive, not touching the keys, just letting it kind of coast over the surface there. Getting closer and closer to the hills. And eventually we arrive. Just waiting for the biome to change. It still says we're in the Great Flats, but we are on the hill. But now it is the lowlands, which means we can stop. And once we've arrived, we can do more science. Repeating all of these experiments. Lowlands is not someplace we've been, so this is all good data. And just dipping the sample collection drill into the ground, collecting it, and falling back. So I don't want to risk, tipping this thing and having it roll head over heels down the hill, because that would be pretty embarrassing if we lost our spaceplane that way. Jonas the Acrobat, we drove here, and then I did a awesome backflip off the plane. Yes. And yeah, just admire. Standing next to the wheels really gives a sense of scale for how big this plane is. The space shuttle, I think always blows my mind, just the true size of it. Could fit 7 people in just the cockpit comfortably with plenty of room to spare. And I was hoping there'd be more biomes, except there's a narrow strip over which we have not surveyed, and we just so happen to be in that strip, and it would take a long time for us to get anywhere else. And I also don't have that kind of patience. The other thing that we're here for that I immediately remembered as soon as I started moving is we have some cargo boxes inside the payload there, inside the cargo bay. So we have this ground anchor, which should be deploying itself into the ground, but it's not. It's just kind of sitting there. And it took me a bit to realize that I have to actually put it into Stelfred's inventory. From there, I have to deploy it like that, and then it drills itself into the ground. So now we have a solid anchoring point from which we can build some stuff. So we have some batteries, probe cores, antennas, and I was going to have this as a seismic station, except it's kind of useless because I broke the solar panels, and now I'm just going to take the one that was there, because otherwise our Kerbals will die within a few hours, which would be really bad. So yeah, that's just going to be kind of there now. Maybe we can put some stuff on it in the future. But yeah, for now, that's just kind of unfortunate that it's just going to sit there. So now we can start our return using the hill as a ramp, and we just kind of take off now. It's like flying with wings, except there's no air. It's just the centrifugal force. because centrifugal force is not real. If you've taken a physics class, you know. So now just burning ourselves into a 10-kilometer orbit. We're going to have a pretty tight delta V margin, although we should be just fine for actually coming back to Kerbin. We should have a little bit of fuel to spare. The main concern is that having all this junk in the cargo bay is going to mess with my stability. And if you remember, having a ton of fuel at the back of the first flight of this thing ended up causing some problems on re-entry. And that's something I want to avoid when we're going to be re-entering over 3 kilometers per second. Now, doing our burn ends up putting us in a directly polar orbit of Kerbin on our return. And unless I pull off some like absolute miracle in flying this thing, there's just no way I can rendezvous with the space station. Yeah, I'd have to do crazy plane changes while in the atmosphere, and it would just burn off way too much speed, and we'd, you know, stall out and crash probably. So I glue all of these parts together to get rid of our mass, and now we just have this lump of debris floating there. Got us back a bit of delta V, and it should hopefully help us with some stability, removing extra mass that would otherwise probably hurt us. And we can just complete our 200 meter per second burn to return to Kerbin. And yeah, it'll leave us with about 100 meters per second left, which should be enough to fix any errors that we encounter. Get ourselves about 45 kilometers. So the way we're going to fly this re-entry, I've never tested this thing on this kind of trajectory. So this will be a very important test for us. But the way I plan to do it is to do several passes. And in the meantime, we actually have the Sentinel inserting itself into orbit, which, you know, just a moment of timing. And we also have this contract to put it into an orbit where it will monitor asteroids, which we complete. But my plan for the plane is to pass through the atmosphere in several passes, bleeding off speed as we go, and hopefully getting enough control over our trajectory that we can wait until the space station comes back around underneath us and we can try to land there. So as it happens, just the way that we're coming in, transferring the science into the cockpit so that in case something goes wrong, we'll have it. But as it happens, we will pass directly over the space center in our first pass, except I think trying to completely slow down would probably kill us. So I'm going to keep ourselves at a pretty high periapsis. I'm also relocating the solar panel here because it is one of the unretractable ones, and I want to keep it in case I end up being in orbit for a very long time. But then this way we can stow the cargo bay and not have to worry about our solar panel sticking out or breaking or anything. So now coming down behind the planet into the night side we go. A very wonderful palette of colors in the sunset. Orient ourselves and just wait until we enter the atmosphere. So for this first pass, the way I'm going to fly it is by basically pitching up as we go in. So arresting our vertical speed and trying to keep ourselves as high as possible. And yeah, at this speed, almost 3,300 meters per second, we see heating instantly. And now as we pass through our periapsis, yeah, we're getting lots of overheating warnings on all the parts there. So I'm hesitant to actually dip my nose down for a bit because I don't want to burn up. But then eventually, you know, we need to stay in the atmosphere to actually slow down. So pitching down into the ground should help us slow down a bit. And now it's time for our next pass around. So for this one, we fly basically the same approach. We're still going way too fast to reasonably land. So we just pitch up, deploy the aero brakes as well, and I'm keeping an eye on my temperatures. I don't want anything to get too hot. And once we pass periapsis, we flip around, roll over, and start pitching the other way. And this keeps us as deep in the atmosphere as it can, for as long as we can, slowing down relatively high up, but deep enough that we're actually experiencing some aerodynamic effects. You can see we've knocked a whole 1 Mach number off of our speed. It used to be Mach 10, now it's Mach 9. And yeah, we just pancake ourselves now that we have that control, barely bringing our orbit down at this altitude. And now for a final pass. So we have raised our periapsis pretty high up. So I enter the atmosphere nosing down, trying to bring my vertical speed up so that we enter the deeper parts of the atmosphere, and then we'll be able to actually properly slow down. So now that we're experiencing the heating, I think we've done enough of that. The Space Center is also on completely the wrong side of the planet, and you have to stay in orbit for a very long time for it to actually come back around. So my plan is to try to maintain ourselves at this speed, at this altitude for as long as I can, and use this thing's cross-range capability to land us on the South Pole. We've landed on the North Pole before because the North Pole is perfectly flat, but the South Pole is also perfectly flat, and we'll be coming up to it. Now, the reason I like to test flights towards the North Pole is because there's land in between the North Pole and the Space Center, so if something goes wrong, we have some place to touch down. But this is just the nature of the flight. We will be coming over the South Pole. And I don't want to be too reckless with my slowing down here, so you can see keeping myself about 50 kilometers and about orbital speed, just so that I can get enough range to safely make it to the South Pole. I don't want to ditch into the ocean because that would be pretty unfortunate. And just holding this altitude, gradually slowing down, and our vertical speed is dropping ever so slowly there. And then I decide, no, we should probably get lower into the atmosphere because at this pace we're probably going to end up overshooting. Pretty high up, coming pretty fast. We've got a lot of energy, and I can just start to see the sun come up now, and that is going to be the middle of the South Pole. I want to land at some point in the day, but yeah, I'm getting pretty close on my range, so I start flying some S-turns, aggressively bleeding off the speed, falling deeper into the atmosphere now, and you can see the edge of the ice sheet. So now here I start to panic a little because I'm worried I'm going to completely overshoot the South Pole. So pulling a couple of G's in these turns here, and now that the sun has come up, we can really start to make out some clouds and details on the terrain. About 33 kilometers, and we're slowing down at a pretty good pace. The air brakes are getting hot, but everything seems to be okay. I think we will make it at this point. And just flying some S-turns, bleeding off the speed, making sure our flight path is as long as possible over as short a distance by flying big curves. And something I think is bugged with my Ferrum Aerospace, because the air brakes are making us kind of yaw in a weird way, which is not something we've done before, or they've done before. So I try playing with the settings, reducing their opening a little bit, and they seem to have gotten much more effective than they should. So something is up with Ferrum. I'll have to probably update it. But come down for a nice touchdown over the South Pole. Brakes are also causing some yawing, so we use the parachutes and then the brakes to slow down. New biome means new science, so of course we have to do all of these experiments. But yeah, unfortunate that we couldn't get these in a lab to do more processing, but that's just the nature of the flight, that's how it went. Bit of a longer video today as well. The whole thing was about 4 hours that I edited down into just under 30 minutes for you guys. And we'll have to see all of the different uses of this science. Jonas here collecting and restoring everything and clambering back inside. We'll have to see what we can do with this, though, in future episodes. Until next time.